Welcome, ladies and gentlemen. My name is Mr. Davis, and I am the Math Healer. And welcome for joining me into using calculus to determine work. This is example 1. I will give you time to pause the video and copy this problem. Let me read it to you. Determine the work done in pumping all the water from a vertical cylindrical tank 6 feet in diameter and 10 feet tall to a height 8 feet above the top of the tank. Please pause and copy this problem. I will now move it up so you can copy the representative diagram that's drawn here. Please observe that the bottom of this cylindrical tank is acting as the x-axis. That's why y is 0 here. The y-axis is going through the center line of this symmetric cylindrical tank. We have a representative disk here. And think of this disk as being microscopically high. Think of it as being 1/100,000th of an inch thick. This is the distance that this disk is from the top of the cylinder. And the top of the cylinder is 8 feet below where we want to pump this fluid. And here the radius is equal to 3. So please copy this diagram because it will be useful and it will be easier to follow the solution process as we go along. Now let's move on to the next page. Now let's take a look at the solution. As you can see from the diagram, we will divide the water into extremely thin horizontal circular discs. Each disc has a thickness of delta y. A typical disc of thickness delta y has the following volume. Pi times the radius squared, which is 3, times the thickness. And this is in cubic feet. After simplifying, we have that a representative volume of the disk is delta V is equal to 9 times pi times delta y. Again, this is in cubic feet. Now we know that the density of water is approximately 62.4 pounds per cubic feet. So the weight of each disk is 62.4 pounds per cubic feet times the volume, which is 9 times pi times delta y cubic feet. The cubic feet units cancel, and that leaves us in units of pounds. So the incremental force can be represented as 561.6 times pi times delta y, where weight is equal to F sub g, which equals the force due to gravity. Please pause and copy. Continuing on, each disk must travel a distance of y sub I plus an additional 8 feet. So the total representative distance is y sub I plus 8. So the incremental work that must be done on each disk is given as the following. Delta W sub I is equal to the incremental force of each disk times the distance that each of those representative disks have to travel, which is y sub I plus 8. So the incremental work is again equal to delta F sub g times y sub I plus 8. Substituting in our value for delta F sub g, we now have that delta W sub I is equal to 561 0.6 times pi times y sub I plus 8 times delta y. Now remember that work is defined to be the distance through which the force is applied. To determine the total work that was done, we must add all of the incremental work that is done on each disk. The thickness of each disk will be allowed to approach 0. So our work integral now becomes W equals the integral as we go from 0 to 10 of 561.6 times pi times y plus 8 dy. And notice this goes from 0, the bottom of the cylindrical tank, up to its top. And this also covers the additional 8 feet that water will have to travel. So this is where the plus 8 comes into play. So that's taken care of here in this expression. As you can see here, we factor out the constant 561.6 times pi out of the integral. Now we take the integral of y plus 8 dy. So W is now equal to 561.6 times pi times 1/2 y squared plus 8y. And the interval of integration goes from 0 to 10. So now, we now have that W is equal to 561.6 times pi times 1/2 times 10 squared plus 8 times 10. We now have that W is equal to 561.6 times pi times 50 plus 80. W is equal to 561.6 times pi times 130. Finally, we see here that the work is 229,361.3965 foot-pounds. Ladies and gentlemen, once again, my name is Mr. Davis, and I am the Math Healer. This is an example of custom-made videos that are put into a private tutoring site that accompanies the one-on-one tutoring that all of my students receive. Please let me know if this instructional video was clear and easy to follow and understand. Please come and look me up at mathhealer.com. Please have an extraordinary, fantastic, and fabulous day. Once again, I am Mr. Davis. I am the Math Healer.